Good morning, children. This is class 10th, subject mathematics, chapter number 3, pair of linear equations in two variables, lecture number 2. In my previous lecture, children, I made you understand how to represent a pair of linear equation in two variable. There is one more kind of representation of the pair of linear equation in two variable. Before we switch to that, let us recall the previous concept once. In my previous video, children, I made you understand the representation of a pair of linear equation is of two kinds. Number one, algebraic representation. Whenever you will be having any kind of word problem given, using two different variables, you can form a pair of linear equation in two variables. Fine. The another one was the graphical representation. Children, you are very much aware about it that whenever we are going to plot the coordinates which are based on any of the pair of linear equations. So for a linear equation, the graph will always be a straight line. Now the first condition was intersecting lines. When you are going to draw two straight lines which are basically based on the word problem of algebraic expressions, then there is the very first condition which is based on intersecting lines. So here you can see that both the lines are going to be intersect each other. Fine. Another case was related to parallel lines. When again you are going to draw the graph of both the lines, okay, then the graph is basically showing that the lines are parallel to each other. Means there is no point of intersection between both of them. And the third case was coincident lines. Here what you have to do, first of all, you are just going to plot the coordinates of the first line. In the same manner, you are going to plot the coordinates of the second line. When you are going to draw the line, one line will definitely overlap the another one. So this was case number 3. This I have already discussed with you in my lecture number 1. Now the question arises, is it mandatory every time that without drawing the lines on the Cartesian plane or without graphical representation, we cannot judge what kinds of line will be drawn, like whether the lines will be intersecting or they will be coinciding each other or the lines will be parallel? Now the answer of this question is yes, there is another method also. So for that, what is to be done? Basically, that method is based on the ratio of the coefficients of the variable present in a pair of linear equation. So let's start today's lecture. Generalized form of a pair of linear equation in two variables. This is written here, children. This is a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0. What we are going to do here, children, you can easily come to know that a1 and a2, they are the numerical coefficients of variable x. b1 and b2 are the numerical coefficients of y, and c1 and c2 are the constant terms. Now, on the basis of ratio of these coefficients as well as constant, we can judge whether the lines will be intersecting or they are coinciding each other or the lines are parallel. So case number 1, if a1 upon a2 means the coefficient of x in first equation and the coefficient of x in second equation is not equal to b1 upon b2. What is b1, b2? Coefficient of y in equation number 1 and coefficient of y in equation number 2. They are not forming the equal ratio. Then the lines will be intersecting to each other and having exactly one solution, or I can call it a unique solution. You have seen in the previous video, even I have shown you just now also. See, this was the graph of the intersecting line. Here you can see, children, that both the lines are going to be intersect each other exactly at one point. So that very point will be considered as the solution of the pair of linear equation. So that's why it is said that exactly one solution will exist. And what kind of system it will be? The pair of linear equation will be called consistent. Fine. Whenever the solutions are going to be exist in that case, the system of the pair of linear equation will be consistent always. But if there is no solution existing, like in the case of parallel lines, then the system will be inconsistent. Okay, let us switch to the case number 2. If a1 upon a2 means the coefficient of x in equation number 1 upon coefficient of x in equation number 2 is equal to b1 upon b2, that you know very well. What do we call them? Is equal to c1 upon c2, means the constant terms. Constant in equation number 1, constant in equation number 2. They all are equal. Then what can we say? That the lines are coinciding each other and there will be infinitely many solutions exist. That again I have shown you just now. One line will overlap the another line. As children, the solutions are going to be exist. So it will be consistent system again. Understood? Okay. Now I am going to switch to case number 3. If a1 upon a2 is equal to b1 upon b2, but they are not equal to c1 upon c2, means coefficient of x in equation number 1 divided by coefficient of x in equation number 2 is equal to coefficient of y in equation number 1, coefficient of y in equation number 2, but they are not equal to the ratio of the constant term, then the lines will be parallel to each other and will be having no solution. So as there will be no solution, means the system will be called inconsistent. Are you getting me? Fine. Now, for better clarity of the concept, I have taken one question, that is question number 2 from exercise 3.2 of NCERT. On comparing a1 upon a2, b1 upon b2 and c1 upon c2, find out whether the lines representing the pair of linear equations intersect at one point, means whether the lines are intersecting or they are parallel or they are coincide each other, right? So this is first part which I am going to take. 5x minus 4y plus 8 is equal to 0. 7x plus 6y minus 9 is equal to 0. Now, because I have to find basically the ratio of the coefficients, so definitely both the equations must be compared with the generalized form of a pair of linear equation. So on comparing the given equations with the standard, or I can call it the generalized form of linear equations. Now I am comparing them. You know children, what was the generalized form? That was a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0. So after comparing, you can come to know that a1 is 5, b1 is minus 4 and c1 is 8. a2 is 7, b2 is 6 and c2 is minus 9. Now, here you can see that 5 upon 7 is not equal to minus 4 upon 6. Means a1 upon a2 is not equal to b1 upon b2. So means the lines will be intersecting. If lines are intersecting, then how many solutions does it have? Yes, it will be having one solution and the system will be called consistent. Getting? Okay. Now, I am going to take second part of the same question. Please pay attention. This is 9x plus 3y plus 12 is equal to 0. 18x plus 6y plus 24 is equal to 0. Again, I am going to compare a pair of linear equation with the generalized form. Through that, children, you know a1 is 9, a2 is 18. b1 is 3, b2 is 6. c1 is 12, c2 is 24. Now, 9 upon 18 is equal to 3 upon 6 is equal to 12 upon 24. All are equal to 1 by 2. It means a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So when all the ratios are going to be equal, then what was the condition? That lines are going to be coinciding each other and the system will definitely be consistent because there will be infinitely many solutions existing. Now, same question, third part I am taking. 6x minus 3y plus 10 is equal to 0. 2x minus y plus 9 is equal to 0. Again comparing, a1 will be 6, a2 will be 2. b1 will be minus 3, b2 will be minus 1. c1 is 10, c2 is 9. See children, 6 upon 2 means that is 3 upon 1. This is 3 upon 1 and this is again minus 3 upon minus 1. Minus sign are going to be cancelled. So 3 upon 1 is equal to 3 upon 1, but they are not equal to the ratio of the constant values. Means A1 upon A2 is equal to B1 upon B2, but that is not equal to C1 upon C2. So the lines are parallel. No solution exists and the system will be inconsistent. Correct. Now, in such kind of questions, basically, sometimes it is asked. Suppose if the solutions are going to be exist, like I told you, for consisting, coinciding as well as for unique solution, there will be the solution existence. Now suppose if he asks, find out the solutions as well using the graphical representation. Definitely in the same manner you have to do as I explained you in lecture number 1. Using this particular pair of equations, you have to find out the coordinates, means x as well as y, means abscissa and ordinate. Then plot them, both the lines will be represented on the Cartesian plane. Through that you can judge, as you will be knowing, that whether the lines will be intersecting or they will be coinciding. So through that you can easily come to know that which solutions will be existing. Okay, for that, for better clarity of the concept, I am just going to take one more question in which the solution is also demanding, right? Half the perimeter of a rectangular garden whose length is 4 meter, more than its width is 36 meter. Means this 36 meter is basically the half of the perimeter of a rectangular garden. Find the dimensions of the garden. So let length of the garden be x meters and its width be y meters. Children, you know very well how to calculate the perimeter of the rectangle, that is 2 into length plus breadth. So 2 into x plus y. Correct? Now, according to question, half of the perimeter of a rectangular garden. So perimeter was what? 2 into x plus y. I am going to take its half. Both are going to be cancelled. And it is equal to 36. So through this I have come to know that x plus y is equal to 36. Understood? Now, what else is given? That length is 4 meter more than its width. Length is x. This is more than its width by 4 meter. So means x is equal to y plus 4. So through this again I have calculated one more equation, that is x minus y is equal to 4. Now children, what I have to tell, basically here through graphical representation I have to tell what will be the length and what will be the breadth. So first of all I have taken one equation, that is x plus y is equal to 36. So through here you can calculate the value of y. Y is equal to 36 minus x. Now here in place of x I am going to put 20. So definitely 36 minus x will be 16. If we are putting x is equal to 24, then 36 minus 24 will be 12. So which coordinates basically I have got to be plotted? That is 20, 16 and 24, 12. Getting? This we have done. This is not new for you. Now table for the another one, that is x minus y is equal to 4. So what will be the y? That is x minus 4. Correct? Now I am going to insert the different values of x so that I can get the different values of y. X is equal to 10, so y will be 6. X is equal to 16. So here if you are putting 16 minus 4, you will be getting 12. So what are the coordinates? 10, 6, 16, 12. Now the graphical representation of the same. Look children, this is the Cartesian plane. Here this is x-axis, this is y-axis. Fine. Just this is very simple. Here I have taken the gap of 2, 2. Here also for my convenience I have taken the gap of 2, 2. What were the coordinates? The coordinates were 20, 16. Means you have to take x coordinate as 20 and y coordinate as 16. Getting? The next coordinate was 24, 12. So from x I have taken 24 and from y I have taken 12. Getting? So these were the two coordinates which I have plotted over here and I have just drawn a straight line. Fine. And here I have written straight line as well. This is x plus y is equal to 36. In the same manner, next two coordinates will also be plotted. Now again the another line is formed. Look, you can see which were the coordinates. 10, 6, 16, 12. 10, 6 will be here and 16, 12 will be here. Now again another straight line is formed. Through this you can easily judge that the representation, what kind of representation it is. It is graphical representation and the lines are intersecting to each other. At what particular point they are going to intersect? They are intersecting at 20, 16. Means the length will be 20 and the breadth will be 16. So through this you can easily calculate the solution of a pair of linear equation. Now the last question, which is very much important. You will be having a linear equation given, that is 2x plus 3y minus 8 is equal to 0. Children, using different condition like intersecting lines, coinciding lines as well as parallel lines, you have to form some more equations using the same given equation. Fine. Write another linear equations in two variables such that the geometrical representation of the pair so formed is number one, intersecting lines. So for intersecting line, children, you know very well, you will be having given equation is this. For intersecting line, what is the condition? A1 upon A2 should not be equal to B1 upon B2. So what kind of equation you can take for that? You had this equation given. 2x plus 3y minus 8. Look, which one I have taken now? Any line which is intersecting with equation number 1, it can be 3x plus 2y minus 9, 3x plus 2y minus 7. Why? Because the same condition should be fulfilled. Means A1 upon A2 must not be equal to B1 upon B2. Here if I am going to take A1, what is A1? 2. What is A2? 3. What is B1? 3. And what is B2? 2. So 2 upon 3 is not equal to 3 upon 2. 3 upon 2 is not equal to 2 upon 3. So through this definitely we can come to know that the lines will be intersecting. Now the next is parallel lines. Same equation you had. The condition for parallel lines is A1 upon A2 is equal to B1 upon B2 but not equal to C1 upon C2. See children, this was the standard equation. 2x plus 3y minus 8. I am going to keep both of them all together so that you can better understand. A1 upon A2. What will be A1 upon A2? This is 2 upon 6. Means I have got 1 upon 3. Correct? Now I am going to take 3 upon 9. That will also be 1 upon 3. But in question it was given minus 8 and here it is I have taken 7. So means 1 upon 3 is equal to 1 upon 3 but not equal to 8 upon 7. So means the condition for the parallel line is satisfied. You can take as many as equation, that depends on you, but the condition should be satisfied. Now the third is for coinciding. A1 upon A2 must be equal to B1 upon B2 must be equal to C1 upon C2. So whatever equation you will be having, you can take multiple of 2, multiple of 3 using the same equation. The same I have done here children, just to see. 2x plus 3y minus 8 was the equation. I have just multiplied the complete equation by 2. So what I have got? 4x plus 6y minus 16 is equal to 0. So that A1 upon A2 must be equal to B1 upon B2 and C1 upon C2. They all three must be equal. Understood? You could even multiply it by 3 also. I have multiplied by it 3. So what I have got? 6x plus 9y minus 24 is equal to 0. Understood? So now what will be your maths homework? You have to do question number 3, question number 4 and question number 7 of exercise 3.2 of NCERT. Thank you children.